So our research group, it's a very interesting story because we work in a multi-center team, and we work together, the Netherlands, Brazil, France, and we try to combine what are the resources that we could use for all the different countries, some being high-income countries and some being like Brazil, low and middle-income countries. And we noticed that some AML patients, they have different metabolic profiles. So some AML patients, they have a very dependent mitochondrial metabolism, and these guys usually are the ones that present some mutations that are very common and associated with poor prognosis, such as the FLT3 ITD mutations. And some patients are FLT3 wild type, and they have a more stem-like kind of leukemia, which are more glycolytic state. So using a technique that could be very easy to apply in different centers, we determined the amount of mitochondrial DNA that one leukemic cell would have, and we defined these AML patients in having equal amounts of mitochondrial DNA content to normal health donors versus AML patients with high mitochondrial DNA content. If we use now this marker, that's a very easy marker that any lab could perform because it's just a simple PCR, we can now give back to the clinicians a tool that would help them to classify and distinguish patients with high disease-free survival and low disease-free survival. So that's actually the whole goal of the project. So we performed a couple of assays to really prove that this marker was associated with a specific metabolic state. But the whole idea is that we can give it back to the clinics, a simple tool that we could use to stratify better EU patients when we decide which kind of treatment they will receive and which kind of approach we will do with them.